All right, so Mr. Wright just went over the two methods we've already used for solving equations. What were the two methods we've already used? Shannon? Substitution, yep, and graphing. Okay, so today we're going to look at elimination. Elimination is actually when you get to more complicated problems, this is the method they use. Substitution is okay when you only have two letters, but when you get to more complicated problems, substitution's not that easy to do. Okay, elimination is kind of the method that you use for more complicated problems. So the goal with elimination is to have two things that add together and cancel out. Okay, that's the goal of elimination. So what's underlined in bold, put that down on your notes. Okay, so just like Mr. Roy did in the notes, he said 2x, right? Gave you that expression. Does anybody remember what was the opposite of 2x? Yeah? Negative 2x. And what happens if you take 2 and add negative 2? What do you get? What's 2 and negative 2? 0. Okay, that's pretty much the whole goal. We're going to hope every time we do one of these problems that we have a number in one equation and we have the negative of that number in the other one. And they cancel each other out. Sometimes the number that canceled out will be with x. Sometimes it'll be with y. It depends. All right, everybody have that? All right, I want to go back and look at this one for a second. Out of those three systems, we'll call this one the first, second, and third. Which one has things lined up the nicest?
3.
Well, 1, I don't think 3, I don't think everything's lined up. But 1, right? You've got the same thing in every column. Y is in one column, X is in another column, and then just numbers, right? That's not exactly what we're looking for, but that's the idea. We want to have things lined up in columns. And the way we want to line it up is basically in that order. Okay, we want X, then after the X you're going to see a plus or a minus sign, then you're going to see a Y, and then we put the number on the other side by itself. So it's not exactly what you guys had in the warm-up, but kind of on the right idea. Okay, we're going to line things up in columns. So X's, Y's, and then the number. All right, so looking at that equation, can somebody give me something that's the opposite of one of the terms on the left? Somebody tell me what would be the opposite of one of the two terms on the left? Josh? Negative 2x. So if this was a real problem, I would hope that there's a negative 2x in the other equation somewhere to cancel that out. Okay. What's the opposite of the other term? Yep. For the letter. Negative y. So if this was a real problem, I would be hoping for one of two things. Either a negative 2x somewhere or a negative y somewhere. If I had one of those two things, then I would be able to eliminate it.
Guys, so we're going to make sure it's in that format, x, y equals number. Can anybody else think of another time when we have an equation, we had to follow like a specific format that we've done so far this year? Shannon? Yeah, y equals m plus b. Right? We had to have y equal sign, x, and just a number at the end. Same idea here. It's got to follow that format. It's almost like alphabetical order. X, y, then after the equal sign, you want just a number, just a constant.
All right, so there's three things you're going to look for when you're doing elimination. And Mr. Roy, I think we already said them earlier. Same number, same letter, but opposite signs, different signs.
So guys, that's the same number, same letter, different sign, so one positive, one negative, right? That's what you're looking for, all right? It might not always be that easy. Sometimes you might have to change the equation around a little bit to get what you want, and we're gonna talk about that in just a second. But that's what you're always looking for, right? Same number, same letter, different sign. It might not always be that way. You might have to change something, all right, to make that happen.
Okay, so looking at, we'll call this equation 1 and equation 2. Does anybody see in that equation two terms that have the same number, same letter, but opposite sign? What do you see, Josh? 2x and what's the other term? Nope, 2x and 4y don't have the same number and they're not the same letter.
2x and negative 2.
There you go, net 2x and negative 2x. Same number, same letter, opposite sign. One's positive 2, one's negative 2. That's going to happen in every problem we do today. Okay, so that's the kind of the thing you have to look for when you do elimination. If that doesn't happen, then we have to make it happen somehow. But that won't be till probably tomorrow and Wednesday. Okay, so when we say there's 5 different methods for elimination, it's really 5 different cases, okay, 5 different types of problem. Same technique in all of them, but we're going to start out with the easiest type and then build up to some harder ones. Okay, that's an example of the easiest type, what I just wrote. The x's are already lined up, the y's are already lined up, the numbers are lined up, and you already have opposites right there. So it's already set up for you, kind of ready to go. Okay, here's another example of method 1.
So guys, when we go through this, right? So today, like Mr. Hager said, it might be better to call them cases because we know the method that we're using is substitution. And so if you want to change the cases, you can. If you want to leave it when you get the notes tomorrow, all right? I'll make sure it's changed to cases. But as you guys can see, if we go up, there's going to be 5 different. Today, when we solve by elimination, it's going to be it'll be the easiest way. So you can look at it and say, all right, when we do these, it's going to go from today being the easiest to what we get to on Wednesday being the hardest. What do I mean by that is, as we get going into tomorrow and Wednesday, we're going to have to do something to the equation, right? To one of the equations, or maybe both, to get it to be opposite sign, to get the same letter, same number, opposite sign. Today, it's going to be already done for us. So on the homework tonight, or even on the test on Friday, all right? You can look at this thing, and you can go through. We'll have this on there for you. Make sure you guys can use this. You'll be able to go through and say, "Yep, okay. I look at the problem. This is almost going to be like your menu. You're going to look at the menu and say, "Oh, yeah, okay. I got the easiest case. It's already set up with same number, same letter, different sign. So all I have to do is, you'll see, these will eliminate. In this case, it'll be the y's. I'm just going to add the rest going vertically." Right, so today we're going to do the easiest type. Right? Tomorrow we'll probably add case 2 and 3, and then Wednesday we'll probably add case 4 and 5.
I think
It's
today
gonna be like your menu.
they have to rearrange today.
Yeah,
Yeah.
I mean today you may have to. It won't be set up. There'll be a couple that won't be set up perfectly. They won't be lined up. All right, so you'll have to get them lined up, but it's still going to fit the criteria for this case. You still have the same, right, Marissa?
Yes.
You'll still, what I just said. No idea, so writing that stuff down back there. But like I said, you might have to rearrange today, to get it X, Y, equal sign number, but it'll still already be, it'll all be, this is the easiest way, because it's already set up to eliminate, it's already done. It'll just eliminate, it'll be gone. And then the rest, the other four cases that are on there, we'll just fill them in, as the week goes on.
All right, so this template that you guys are looking at, the same template you have in pretty much every problem today, that's exactly what it's going to be set up like on the test. Okay? You're going to have a spot for each equation, and then you got some spots to show your work.
And guys, you'll see as the week goes on, we might make a few, there might be a few things added, all right, to this template. We might put a couple boxes here, like here and here, because we might have to put a number inside those boxes. We might put a little bit more space here in the middle, because we might need a little bit more space. So even as the week gets going here, and you're not quite sure of what case to use to solve for elimination, look at the size of the template that you're using. This is the most basic. That means probably it's already going to be set up for you. All right? So the first thing when we do this, the first thing you want to do is you're going to ask yourself, like Mr. Hager and I we just talked about, is it lined up? What do we mean by is it lined up? What does that mean? When we solve by elimination, how does the problem have to be lined up? Vanessa?
X have to be with the X's, so I have to be with the Y.
X, okay, so we'll have the equal sign, all right? Over here, on this side, we're going to want our letters, all right? Our X's and our Y's. And then on this side, we're going to want just a number. 5, -2, 20. Doesn't matter, all right? So we want variables X and Y on one side, and then just a number on the other side. So on your notes, you have a little line here to write in, all right? When we do this, when we give you this template on the test or on the homework or something like this, you're not going to have the steps written in, right? But write them in now so you have an example to go back to on your homework to see how it works, all right? So we're going to ask ourselves, we want to add the equations to eliminate, all right? So are they lined up? Are these two equations lined up and ready to solve? How many people say yeah? How many people say yes, they're lined up? How many people say no, they're not lined up? How come they're not lined up, Sad?
Because they don't have the numbers like 1, Y.
Okay, they don't know, it doesn't always have to be a number attached to the variable. All right? Do you agree that y, x is over x, is y over y? Are the numbers over the numbers?
Yeah.
So we're lined up. All right, but it's not a bad question to ask, because the ones we did before, there was numbers attached. I mean, I think somebody else said there are numbers attached. What number is there, even though it's not written? 1, right? Even though we didn't write it. So they're lined up. Good. You're never going to see the system written inside the template. You got to take the template. You got to take the system and write it inside the template. So, Jordy, on this first line, equation 1, what am I going to write?
X plus 4 equals.
Careful. I like x plus.
X plus Y.
Yep. Good. All I'm doing is taking the top equation, or equation 1, and bringing it down. Nini? What's equation 2 going to be?
-X plus Y equals -2.
-x plus y equals -2. Okay. Now, what variable, what am I looking for again to eliminate? What 3 things? Somebody give me one thing I'm looking for. What's one thing I'm looking for to eliminate? What do I need to have? Dominic, what do I need to have? What's one thing I need to have? There's 3 things, what's one thing I have to have? Same. All right. So Ashley said same number, that works. Nini? Same letter. And what's the different thing? Different sign, right? Do I have that with either variable in this problem? Same number, same letter, different sign. All right, here's my system. All right, do I have that with either one? Which one, Jordy? which has, say what you're gonna say.
I don't even know what you said.
Okay. Same number, same letter, different sign. Which variable is set up like that? Which variable will eliminate? Which one are we gonna get rid of? X, why, Liam? Yeah, even though I didn't write it there, I got a 1 here, I got a 1 here. Right? Same, I mean, even though the 1's not written there, I got a 1, I got a 1. The letter is X, X and X. I got a positive 1X, I got a negative 1X. That's gonna eliminate. What I'm gonna do is, just cross it out, because it eliminates.
Now, why did it eliminate? What did he just do with the x and the negative x? Well, how did he cancel them out? Did he multiply them together? No? Added them.
Yep. So we're gonna add those equations to eliminate. All right. Now we're gonna add. That's why you can see this the little dotted arrow here. We're gonna add vertically, up and down. All right. We're gonna do our math going up and down. All right. So I got to combine the y's. I got a positive y here and a positive y here. What do I get?
2y.
2y. And what's the last thing I'm going to add? What are the two numbers? 4 and, careful, 4 and negative 2. What do I get?
2.
Huh? 2, positive 2. There it is. All right, I eliminated. I'm going to take what's written here. All right, the 2y equals 2. I'm going to bring that, and I'm going to put that in the middle box. All right? Because my second step is going to be what? What's it say? Solve the variable that's left. In this case, the x is eliminated, so I have y left. So I'm going to take this type of, in case 1, where it's already set up for me, I already have same number, same letter, different sign. Right? I don't have to multiply or anything like that. It's already ready to go for me. All right? I'll take what's here, I'll bring it into the middle box of my template. And I'm going to multiply, I'm going to solve the variable that's left. Hannah, what do you think I'll do to solve in that middle box? Divide by 2. All right? I'll divide by 2 by what's left in the middle. That will cancel out. I'm going to write y in the circle. What am I going to write in the other circle?
0.
0. Emily, 1. Because 2 divided by 2 is 1. Now, so I already solved for 1, but just like we did with graphing, just like we did with substitution, I have to solve for 2 variables, right? Because there's 2 variables in every equation that we do when it's a system. All right? Aiden, what's it say here?
Plugging the variable into an original equation and solve.
So plug that variable, all right, this y, into an original equation and solve. What do I mean by an original equation? What's that mean? Marissa? Huh? Second, but what does it mean by an original equation? Where would I look at to find an original equation? Where can I find that? Josh? I could look right outside the box, or in this case, I didn't change anything, so I could look in the first box. Or I could look up here. All right? Which equation do we want to use? Top one or bottom one? Use the top one, okay. So the top equation was what again? Equation 1 was what? X equals what, 4? Okay. X plus y equals 4. I think it's a good, I think the top one's, I think either one would be a good choice, all right, because y is positive in both equations, all right? We don't have to deal with a negative if we don't have to, all right? Or this one's a little bit easier because y is by itself in both equations. There's nothing attached to it, all right? If I had a choice, say if this was like a 2y down here and y up here, I'd do the top one because I wouldn't have to do the multiplication part. So when you look for an equation to plug into, try to look for one that already has the variable you solve for by itself. All right? So what's going to happen here? I got y equals 1. What am I going to write below this equation now? Because it says I picked the equation I want to use, but now it says plug in that variable into the original equation and solve. I have the original equation, but I didn't plug in for my variable. What variable did I just solve for? What variable did I just solve for in the middle? Y. I'm going to circle y over here, and I'm going to circle the sign that's with it. I'm going to circle the plus. What's going to happen? Somebody tell me what's going to happen. Liam? Substitute. Okay, tell me more.
You substitute the 1 for y.
Yeah, y, because we just solved for it, is going to become 1. What's my new equation going to be, Liam?
X plus 1 equals 4.
X plus 1 equals 4. All right? Now, I've picked the equation I want to use. I've substituted for that variable. One more step. What's the last step? Solve, right? So, like Liam just said, subtract 1 from both sides. X equals what? X equals 3, and I'm done. All right, so again, this is case 1, the easiest case we'll do. It's already going to be set up for you. All right? You're already going to have same number, same letter, different sign, every time. You're not going to have to do anything to change you're not going to have to multiply the equation by anything to get it to be same number, same letter, different sign.
What's the hardest one to do?
When you have to multiply in both equations, the top and the bottom.
We're not doing that till
I'll do that.
Wednesday.
Cheer up.
All right, so let's just try a couple more of this type, just to make sure we get the method down, and then we'll try one that's a little bit harder, but it's still the same case. All right. How about Ashley? What's the first thing I'm supposed to look for?
What 3 things? What 3 things you... Okay, that's good. Yeah.
Is it lined up? Yeah. The X's are in the first column, Y's are in the second, numbers are in the third. Good. So now, what do I do with those 2 equations that are outside that box? Put them in box 1. Okay? Whatever you put in box 1, we always want it lined up before we put it in the box. Okay?
Guys, that's why we leave it outside, right? Just in case we have to move some stuff around to get to where we want. That's why we have it written outside, to make sure that if we have to move stuff around, we have the space to do it. We're only going to write stuff in that first box that's lined up. Right, Antonio?
Right,
I gotta make, before I write stuff into that first box, what do I have to make sure?
that it's all lined up.
It's lined up. What's that mean?
When all the X's are in one column, all the Y's in one column, and all the numbers in one column.
Good man, thank you.
All right. So now, Derek, what's the next thing I look for? Couple, 3 things. Look at those 3 blanks on that other side. You look for the same.
So same number, same letter, different sign.
Okay, do you see that here? Do you see the same number, same letter, different sign?
Yeah.
All right, what's the number that's the same?
2,
Yep, the 2. What's the letter that's the same?
Y.
The Y. And then what's different is one of them's a positive 2, one of them's a negative 2. Right. So now, what are we going to do with these 2 equations? We're going to take each column and we're going to,
We gotta get rid of one of them.
yep, one of the columns is going to get canceled out because we're going to take these and add them. Exactly. We're going to add them up.
Add them.
What's negative 2y and positive 2y?
Cancels out.
Cancels out. Negative 2 plus 2, that's 0. All right? So what am I going to put down at the bottom? How many, Emma, how many x's do I have?
2.
No, not 2. There's 3, right? 1 there, and then 2. So 3x equals, Marissa, what's going to go on the other side? 3. How'd you get that? Yeah, just 2 plus 1. 2 plus 1 gives us 3.
Remember guys, you're adding vertically, up and down.
All right, now we're going to take and copy this over, so we've got some more space. Vanessa, what do I do here?
Divide it by 3.
Yeah, divide by 3. And Trenton, what's that going to give me?
X equals 1.
Perfect. X equals 1. Okay, let's see. How about Maggie? Are we done?
No.
No, what do we still have to do?
Um, we have to
What do we still have to find?
be,
What's going to go here in these circles? Or specifically this one? Well, this one right here is going to have, we're going to figure something out, but this one, we already know what's going to go there.
the variable?
Yeah, which one? No, we already got the x in the first one. The y. So I know when I'm done, it's going to be y equals something. Okay, how do I figure out y? Yeah, we're going to plug it in. This part is just like substitution now from last week. Which equation do I have to use, the top one or the bottom one? It doesn't matter, exactly. You can use either one. Pick whichever one you think is easier. The bottom one. Okay, let's do the bottom one. 2x plus 2y equals 1. If you got the right answer in this box, no matter which equation you use, you're going to get the right answer in the next box. Okay? If you made a mistake getting x, then it's going to mess up getting y too. Okay, so we've got to make sure we're careful with x. What am I going to, Antonio, what am I plugging in for x?
1.
Yeah, I'm going to plug in 1. It's all I did was change x to 1. And I put it in parentheses, because if I didn't put parentheses, it would look like that. It would look like the number 21. All right, Sabrina, what do we do next in this equation?
Change the 2 times 1 to 2 and plus 2y.
Sure. So 2 times 1 is 2, plus 2y equals 1. And we got 2 steps
Guys,
left.
this one that we're doing right now, 1B, had an extra step in this part. Like the third box had an extra step when compared to the first one we did. How come? We're in that last box. Why does this one have an extra step? Emily?
There's a number attached to x.
Exactly, right? There's a number attached. The one we did before, x and y were by itself, right? It was just x and just y. This one, we had a number attached, so when we plugged it in, we had to multiply. So if the variable's by itself, no number attached, you don't have to multiply. In this case, where you plugged it in, you had to.
Okay, Babe, what would be our next step?
You could wait, divide, subtract the 2 with the, bring it over to where the 1 is and minus it.
Yep,
2 minus 2. And
exactly. You're going to subtract 2 from both sides. So that's gone.
then you want to divide, we'll have to subtract it.
Yep, I did the subtraction. So 1 minus 2 gives me negative 1. And go ahead, what's my last step?
And then you divide the 2 by 2y and then you divide it over there.
So what did you divide by?
2y, but it cancels fractions.
Careful. You're close. We don't divide by 2y.
Just 2.
Just 2. Yep, good. Just 2. Just 2. All right, so what did I get for y? Yep, Maggie?
What'd you get for y, Maggie?
Just kidding, I don't know.
Negative 1 over 2.
Over 2, okay.
Yeah, we can just leave it like that. Negative 1 over 2. Try to make my negative sign look like it's not part of the fraction. Okay. How many people like this better than graphing? I think it's a little faster. How about versus substitution? Where you're going to get the letter by itself and then plug in, and then sometimes you have distributive property. You like this better? Yeah, it works out pretty nice when the numbers are already lined up for you. What's that?
Try this one?
Sure. Yeah. Why don't you guys take a minute, try to start this one, at least get to the step where you figure out what letter is going to be eliminated. Okay, try to do what you can.
And guys, remember, we're using the method of,
We're sticking about this one.
guys, we're using the method of substitution, right? In what case did we say we're going to get every time today? What case will we get? Huh? What case are we going to get every time? It's already going to be set up for you guys. You're always going to have same number. What we do today, you're always going to have same number, same letter, different sign for one of the variables. It's the easiest case that we'll do for elimination today. Right? It's already going to be same. The stuff we're doing a little bit might be, you have to move some stuff around.
All right, so do we have everything lined up here? What do you think? X is in a column, Y is in a column, numbers in a column. Yes, if you already have that, just copy the problem into the box one. If you don't, that's what we're going to do next. Okay. So negative 2x plus 3y equals 2. That should be equation 1. Equation 2, 2x plus 7y equals 18. What letter is going to disappear here when we add these up? That's in a bad spot. Well, there's a negative there. You just can't see it. Yeah. Yeah. The negative 2x is going to cancel with the positive 2x. Those are going to cancel out. And now add what's left. Natalie, when I add up my y's, what do I get? Good. 10y. And now add up my numbers. Antonio, what's 2 plus 18? 20. Now, Iselis, what do I do with this equation? Yeah, we just put it in the other box to give us a little more room because we're kind of running out of space here to finish solving. So we get 10y equals 20. Ariel, what's my last step to solve that for y?
Divide by 10.
Yep, perfect. Divide by 10. And I get y equals, Aiden, what do I get for y?
Y, you're going to get 2.
2. Okay, any questions on that? Okay, so on a problem like this, what I'm going to look for is, did you line everything up? It already was, so we don't have to worry about that. Did you get y? And then did you get x? Okay, so we still got to get x. Which equation looks easier here? The bottom one?
Yeah.
Maybe the bottom one, because you don't have a negative in front of that x. Okay? The bottom one, the numbers are a little bigger. You're going to have to deal with the 18 instead of the 2. But we can use the bottom one. And if I use the bottom one, or if I had used the top one, what letter am I going to fill in for? Y. And what are you going to fill in for it? 2. So 2x plus 7 times 2. If you want to do that in one step as you do it, just write 14, that's fine. Or if you don't, we got to now do it out. All right, so 2x plus 14 equals 18, and I have 2 steps left. Yep. Good. I'm going to subtract 14. That's gone. And then I get 2x equals, what's 18 minus 14? 4? And now I'm down to my last step. Yep, divide by 2. And divide by 2. What's 4 divided by 2? 2. And there's my answers. Y equals 2, x is 2. In this case, they came out the same. All right, so how many people feel pretty comfortable with that type? Where it's already lined up for you, you just add them the way they are. People feel okay? All right. Well, we're going to try example 2A. So if you're still having trouble with example 1, example 2 is going to be almost the same thing. Okay, we just have to do one thing first. Okay, so in the previous problems, the x's, the y's, and the numbers were already lined up. Okay, what's wrong with example 2A? And I think on your paper, you guys have it spaced out like that. That's fine. But if I put it back like this, I think it makes it easier to see. What's wrong here? They're what? Yeah, things are switched. Okay. Is either one of these equations the way it should be? No. What's supposed to come first?
It's the X and Y.
The x's could be a plus or minus, then the y's, and then what's on the other side by itself? The number. Do either one of these equations look like that?
No.
No. So we need to fix them. Okay, so I'm going to just move this over here. And let's start with the 2x equals 3y minus 5. There's only one thing in both of these I have to do. What do I have to do to make this equation look more like that?
Which, if you look at that, I mean, we're not so much worried, which variable is in the wrong place? Which variable's in the wrong spot? Where should the variables be, on the left-hand side or the right-hand side? The letters, it should be on the left or on the right?
Where's that? Yeah.
Okay.
Yeah, so how would you put everything on the left? The 2x is already there. It's the 3y, that's the problem. Yeah? Perfect. Subtract 3y. And when I do that, Marissa, can you tell me what's on the left-hand side now? You know what, you don't have to worry about the plus too much. Just 2x minus 3y. 2x minus 3y. What do I get when I combine 2x minus 3y?
See, 2x equals 2y minus 1. It's changing around.
You can't, because they're not like two.
Exactly, I can't. These are not like terms. You can't combine an x and a y. Good job. And negative 5 is on the other side. Okay, this equation is good now. I'm fine with that one. So in a minute, we'll copy that into equation 1. How about equation 2? What's wrong with this one? The 3y is where the number should be on the right. All right, so the number is in the right spot. Yeah, it's supposed to be with the x, so we need to move the x to the left. How would I move 4x to the other side? Subtract it and subtract it. Now, anybody think they can tell me what this comes out to, but I need it in the right order? X first, then the number. What would be my first term?
Basically, Mr. Hager he hasn't written vertically. He's just going to make sure it's written in the correct order when he writes it horizontally or going across. So he's going to take it from going up and down and write it across and just make sure it's in the right order.
For example, would I want to write this? No. It's not that that's wrong, but it's not going to help me. It's not the order that I want.
Maybe 4x minus 3y?
Careful, what kind of 4 is it?
Negative
It's a negative 4x
There's no sign to the left of that 3y.
So, times
This is what you said.
Put the sign there. What sign is it? It's a plus. So what would go right after the negative 4x?
plus 3.
There you go. Yep. This and that are exactly the same thing. It's just we want it with the x first, like y equals mx plus b, right? We want it in a certain order. It's the same thing here, alphabetical order. And then what's still on the other side? 1. Great. Is that equation in the right order now? Yeah, that one's good. So now, what am I going to write on the equation 1 line? Yes. So in this problem, this time I would grade what you put on the equation 1 line. Why? Because it wasn't given to you. You had to figure this out. Okay, so you would get partial credit just for getting this. And what's going to be equation 2? Negative 4x plus 3y equals 1. Okay, on this kind of problem, if that's how far you got, I would give you half credit. Because you got 2 out of the 4 things we need to find.
Now, guys, when we rearranged it, guys, do we make any changes to the template itself? All the boxes and the circles, did anything change there? Anything get added? Anything different from the ones we've used? No. It's still gonna be case 1. All right? We're still gonna be solving with elimination, but it's still gonna be case 1.
Okay, now can somebody guide me from here? What do I do? This is just like what we did in example 1. Antonio?
The x's cancel out because they're opposite.
Does everybody think the x's cancel?
No.
The y's. Okay, the y's cancel out. What do the x's add up to?
2x.
Careful. It's a
No,
negative 2x. And what about negative 5 plus 1? Yep. Negative 4. All right. Now I'm running out of some room, so I'm just going to copy it over here. And my next step, I should know what x is. How about Josh? Can you give me my last step to get x? Divide by negative 2. Divide by negative 2. And what's x? Positive 2. Good. Now, how do we get y? What do we have to do with x? Plug it in where? Yeah, we're going to go back to one of the original equations. Okay, so I kind of wrote over it, but if I just move that stuff away from it, that was one of the original equations. And this was the other one. Okay, which one of these do you want to use? You can use the first one or the second. The second? Any reason why did you pick the second? Okay, because we don't have a negative. The numbers are a little bigger in the second one, 3 and 4, but they're not too bad. All right, so let's use the second one. 3y equals 4x plus 1. Now what? Yep, and what do you plug in for x? 2? And let's do this as we go. What's 4 times 2? 8 plus 1. 9. And I have one step left. Divide by 3. And that means y equals 3. Okay, so a little bit harder than the first type, but not too bad. All you got to do is rearrange it by moving something to the other side first. Okay, any questions on that one? I know we put 2a, but there isn't a 2b. Okay, the next one is example 3. We're not going to do that one there. I'm going to show you the one we're going to do. Okay, it's a little different. We're not going to do that rectangle one. Nope. You can cross it out. Yep. Yep. We're going to use the boxes though. But you can cross out the length of a rectangle is 5 inches.
And guys, cross, for example 3, cross out that word problem. No, not the whole thing, just the word problem itself. We're going to use the boxes. So you can cross out the word problem.
You said cross out though.
All right, so the one we're going to do is about 2 packages. Okay, so it says 2 packages together have a weight of 39 pounds.
Guys, if you can squeeze this in and make it fit, great. If not, just write down the actual, we plug it into the boxes. But if you can squeeze it in, that'd be great.
Okay, so 2 packages have a weight of 39 pounds. So how many things are we dealing with here? 2 things. Package 1, package 2. We need to pick names for those. Okay, so we'll have to figure that out in a second. We could pick variables x and y. We could pick whatever we want. The second thing they tell us is 1 package is 7 pounds heavier than the other. They want to know how much each package weighs. Okay, so the 2 packages weigh 39 pounds. 1 is 7 pounds more than the other. Find the weight of each package. Okay, on this problem, there'd be 4 things I'm going to grade. Equation 1, equation 2, and then the weight of package 1 and the weight of package 2. All right, so what do we want to call package 1? We've got to pick a letter for it.
P.
B?
P.
P. All right. And what do we want to call package 2?
A.
A? All right. We just have to remember P is package 1, A is package 2. It says 2 packages have a total. What do you do when you total something up? What, Josh? You add it together. 2 packages have a total weight of 39 pounds. Can anybody finish that off and make it into an equation? Equals 39. Okay, at this point, we don't know, does package 1 weigh 10 pounds and the other one is 29? We're going to figure that out. Okay, but the 2 packages added together equal 39. 1 package. Okay, it doesn't matter which package you pick. So somebody pick one of the packages. Package A. So let's say package, I'm going to call this package A, is 7 pounds more than the other one. So package A is, how would you write 7 pounds more than, what do we call the other package? Oh, P. What would go on the other side?
P plus 7.
Exactly. 1 package is 7 pounds more than the other. Now, does either one of these equations look kind of like what we did in example 1 or 2? I mean, it's different letters, but is the setup of one of these equations look correct? The top. Your letters are on the left. Your number is on the right by itself. So the top equation is good. We don't have to do anything to it. How about the bottom one? Yeah, what do we have to move to the other side? The P. Okay, we're going to put the P on the other side. How do we move it to the other side? Josh? Yeah. Subtract it. and subtract it. So I'm going to put a box around that so I don't get confused. That's going to be my first equation. Who can tell me my second equation? All right, I like equals 7. That's good. And what letter do we want first because of the way we set the top one up? P. And is P a positive or a negative? It's a negative. And what's going to come after that? Josh? Yeah. If you want to put the sign in, it's a plus A. Plus A. Is the second equation set up just like the first? Perfect. Okay, so I don't have the same template you do, but under equation 1, put down P plus A equals 39. Aiden, what's going to go under equation 2?
Negative P plus A
Equals 7. Perfect. Now, what letter there is set up to eliminate? It automatically, it's just going to disappear. P. Positive P, negative P. If we add these up, what's going to be my new equation? Yep. 2A equals 46. And now what we normally do is copy that over to the second box. And we solve for A. What? Divide by 2. So how much does package A weigh? 23. So at the bottom of box 2, put A equals 23. And what was it? 23 pounds. So since it's a word problem, I'll just put my label on it. All right. Which equation here would be easiest? Well, actually, go back to the original. Which one is easiest to use? The first one or the second one? Yeah, I would use the first one. P plus A equals 39. Okay, so in this is box 3. I just ran out of space. P plus A equals 39. What letter do I already know? A. How much does package A? Yeah, it weighs 23 pounds. What's going to be nice about solving this one, nicer than the last couple? There's no multiplication, right? It's just a 1 in front of the P. So we're going to do one step and we're done. What's my last step? How much does the package we call package P weigh? 16 pounds. If you add 16 pounds to 23 pounds, do those packages weigh 39 pounds together? Yeah. Okay, so homework tonight.
You guys don't smoke? Does anybody not get a homework?
Okay.
Anybody else not get a homework?
Mr. Ray, you want him to skip number 5?
Yeah, it wasn't like that one, it was a rectangle.
Okay, so on the homework, you can cross out number 5.
Guys, yeah, why don't you have time, you have like 4 minutes. If you can find your homework, why don't you cross out question number 5? You don't have to do it. You only have to do the first 4.
Okay. And guys, because this is the last week of the term,
Guys, stop listening for 1 second so we know what's going on this week.
because it's the last week of the term, what we're going to do is we're going to start the test on Thursday this week. Okay, we're going to start it Thursday and finish Friday.
Yeah, so guys, it'll be a little bit different this week. We're going to give you the reference sheet on Wednesday for homework. All right, so the first, obviously we said we're going to have different types of ways for substitution. Guys, listen for a second so you know what's going on this week. Look at me so I know you're listening. Look at me so I know you're listening. The homework on Wednesday, all right, is going to be usually get the reference sheet Thursday night, but because we're going to start the test on Thursday in class, we'll give it to you Wednesday night. Then we'll review the first half of the class up till about 2 o'clock on Thursday. Second half of the class, we'll start the test.